All right, so let's get going on today's class. So what we're going to do today is we're going to continue our look at confidence intervals, aka Chapter 8 and 9 revisited, because many of the skills and techniques that we're going to be using to calculate these confidence intervals derive from the work that we did with t-tests. One more time, getting back to confidence intervals, which again is going to use the skills that we developed for doing t-tests in Chapter 8 and Chapter 9. So last time we met, pre-Thanksgiving, we went through the example that had to do with the monkey sanctuary. And just to remind you, confidence intervals, one of their purposes is often used in real-world applications. So whereas for a psychologist, for a theoretical psychologist in a lab, usually we're testing to see if there's a difference. Is there a difference or is there no difference? Do we reject the null hypothesis or do we reject the research hypothesis? And that's good enough and exactly what you need as a theoretical psychologist. You just want to know how things work. But in the real world, sometimes you need to know how much of a thing is there when you're dealing with situations such as budgetary concerns, where you need to determine how many terry cloth monkeys will you need while there was a virus outbreak in your zoo and you have to quarantine the parent monkeys, and now you want to make sure that the infant monkeys have something soft to cuddle to keep them occupied. How many do you need to make sure that there's enough for every monkey? How many of these do you need without going over budget? So you're trying to buy as few terry cloth monkeys as you can, but making sure that you have enough. And that's where we need that confidence interval of how long does each monkey spend with the terry cloth mother. So what we're going to do today is we're going to go over two more examples to take a look at confidence intervals. And we're going to see an example that has to do with Loftus and Palmer's work on eyewitness memory. So again, for a psychologist who is studying memory and studying how memory gets reconstructed, the fact that how you phrase a question changes people's memory for the events, that's what we need to know. That's what drives the theoretical work in psychology. But sometimes in the real world, you end up in a situation like, for example, a court case where a question was worded incorrectly and now a eyewitness's memory has been tainted. And you need to know not that it has been affected, but you need to know by how much. How much of an overestimation is this eyewitness now going to make because of the way that the question was asked? And that's a confidence interval question. And then lastly, we're going to take a look at the increase in accuracy that you can expect when you put people into a 5-second timeout condition versus a 10-second timeout condition. And if you were a businessman thinking of putting this into effect in your company, then you need to know, is the trade-off in accuracy for a 10-second timeout condition worth the 5 seconds gone in terms of your workers actually working? So is that increase in accuracy going to be worth the fact that you're losing, in essence, 5 seconds of work every time a mistake is made? And in that case, you don't want to know just that it's more accurate in the 10-second condition. You want to know what increase can you expect? How much of an increase can you get? That is a confidence interval type question. So that's what we're going to be looking at today. And as we saw yesterday when we took a look at the first confidence interval, this is stuff that you have been doing unknown to yourself. So much like Dorothy in The Wizard of Oz, who always had the power to go back home, but only found that out at the very end. You're going to see that you have been calculating confidence intervals this whole time, and now we're going to just point out the fact that you have been and see how to interpret that information from SPSS. So what we're going to be doing today is just, once again, a quick overview, recap of confidence intervals. Then we're going to dive right into SPSS. We're going to take a look at the dependent means confidence interval and the independent means confidence interval. And then I'll mention, we'll have some time for in-class homework, and I'll mention about the homework assignment, which is your final Excel homework assignment. All right, so confidence intervals are these intervals that are surrounding a point estimate. So the center of your interval is always your point estimate. It's always your best guess. If you were going to give one number to estimate an unknown quantity, that middle of your confidence interval is your best guess. But then what we do is we have a range around that best guess that is your interval estimate. And by making the range as wide as the body of this distribution, and you can choose how wide you want to make the body of that distribution, by making it that wide, we get a confidence at that level. So if this body here is 90% of the distribution, and we make this interval as wide as the body, then 90% of our samples, 90% of our center point estimates are going to come from this body. And as long as your sample came from the body of your distribution, right? Again, we don't know where our sample came from. That's the challenge. But as long as your sample came from the body of this distribution, your interval estimate is going to cover the mean that you're trying to estimate. Your interval estimate is going to cover that unknown quantity that you're trying to estimate. So it's going to be a successful estimation. And it's only when you're unlucky enough to end up with a sample that comes from the tail that your interval is going to miss that estimate. So if you have a 90% chance that your samples will come from the body because you made the body 90% of the distribution, you only have a 10% chance that it's going to come from the tail. So you have a 90% chance that your estimate is going to correctly estimate that unknown quantity. You only have a 10% chance that your estimate is going to miss it. Therefore, you have 90% confidence that you estimated correctly. You have a 90% confidence interval. And as we saw, this confidence interval is based on your t-statistic equation, and we just solved for the population mean. And this is the format that we want to get each confidence interval into. And that's part of the challenge of going from SPSS to this form, because this is the form that most people are familiar with. Most people, when they report a confidence interval, they will say that the thing that you're trying to estimate, the population mean, equals something plus or minus some amount of wiggle room, some amount of error. And that is this format right here. So we want to figure out what is it that we're estimating, that population mean. We want to have that as equal to the sample mean, or the best guess, your point estimate, the center of your distribution, your interval, plus or minus some interval here. So again, now that we're in the thick of the election season, you will oftentimes hear people saying, oh, so-and-so is polling at 40% support, plus or minus 3%. That's what they're indicating. They're saying that's our best guess, 40%, plus or minus 3% will give you a certain amount of confidence. All right, so that's a brief recap. So what we're going to do now is we are going to do a couple of more practice problems for how to calculate these intervals. So we have already done Harlow's monkey study. So that was in the lecture from last class. And we saw how to estimate how long do these monkeys spend with the terry cloth mother. Not just that they spend more time with the terry cloth mother, but actually how much time do they spend with the terry cloth mother. And today we're going to take a look at Loftus and Palmer's study on memory and see if we can find a confidence interval for how much was the memory overestimated. What was the amount of overestimation of that memory? So once again, this would be used, for example, if you were called in as a psychology expert witness in a court case because the prosecutor phrased a question like this: when the car violently and egregiously smashed into the truck, how fast was it going when it smashed into that truck? Well, that witness's memory is tainted. So when that witness says, oh, the car was going 70 miles an hour, you need to know in the court case, was that overestimated by 10 miles an hour? Was it overestimated by 5 miles an hour? Was it overestimated by 15 miles an hour? We've already done the test that shows that she overestimated her memory for the event. Now we need to figure out how much, because that can mean the difference between a guilty verdict or an innocent verdict. All right, so we have our situation once again, and when you are doing your confidence intervals, the very first thing that you need to do is you need to figure out what t-test you need in order to calculate this confidence interval. And the t-test is based on the experimental design. So the same way that we chose what t-test to do before, we choose what t-test to use now in the same way. So for example, here in this confidence interval for the independent mean statistic, we would read the description and we would see that students watched a film of an automobile accident and then were then asked how fast were the cars going. We're then asked what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb hit was changed into smashed into instead of smashed into. So you need to, again, identify we have two separate groups, each measured once. That's an independent means t-test. So to calculate a confidence interval, we would do an independent t-test in this situation. So the independent t-test wanted to know, do the results indicate a significantly higher mean for the smashed into group? Use the two-tailed test with an alpha 0.05. We've already done that. We've already seen, yes, there is a significant difference. Yes, the population that is asked how fast were the cars going when they smashed into each other does have higher estimates of speed. So now we're going to ask, though, all right, we figured out that the estimates are higher. Now we want to know how much higher are they? How much faster are the estimates for the smashed into group? And we are going to compute a 95% confidence interval, we're going to compute an 80% confidence interval, and we're going to compute a 99% confidence interval. So at this point, if you haven't already, fire up SPSS, and I will do that as well. So again, just make sure that you're ready to go as I get my own stuff up and running. All right, so while that's coming up, so once again, this in your Excel sheet, this is demo question number 2. We did demo question number 1 last time we met. So in demo question number 2, much like doing an actual t-test, to do the confidence intervals, you need the raw scores. So you need to have the actual individual scores. In order to use SPSS, you need to have the individual scores for each and every subject. So we have those, so we are good to go in that regard. So the other thing that I'll mention for this is we've already gone through how to format a t-test for an independent means t-test. So because we've already done that, I do have it pre-formatted and ready to go in Excel. So that is right below the t-test there. So we just have to, again, wait for my SPSS to fire up. And then we can just take this and we can copy and paste it directly. And notice once again that we have each subject on an individual row, and we have the speed estimates in one column, and then the group names, which are smashed and hit, in the other column. All right, so once again, we have SPSS open, ready to go. So we need to put in our data. Our data is pre-formatted here just to expedite matters. So we can copy and paste all of the data, including the speed estimates and the group estimates. So we go in, we paste those in to SPSS. Once again, let's make sure that we label these correctly. So var 00001, those are the speed estimates, so we can call those speed. And var 00002, those are the group names, so we'll just name that group. So now we have it correctly formatted, and in order to calculate the confidence interval, we have already decided that it is an independent means t-test. So we go to Analyze, we go to Compare Means, we go to Independent Samples t-test like we always have. The test variables is going to be speed. The grouping variable down here is group, and then we define the groups, and the one group is called smashed, and the other group is called hit. And then we hit continue, and we pause. So we pause right now because this is what we would need to do in order to do the t-test. We'd be ready to go for the t-test at this point. In order to do a confidence interval, you then go to options. So that's what the option buttons up here is for. It should really just be called confidence interval because that's about the only real option that it has. So we go to options here, and we got confidence interval percentage, and that is at default listed at 95%. So the same way that an alpha level of 0.05, aka 5%, is the most common alpha level, a confidence interval percentage of 95%, right? The reverse of alpha is your most typical confidence interval percentage. So we go back to our PowerPoint just to make sure that we got the right confidence intervals that are being asked for. So it said a 95% confidence interval. So that is the default. That is all set up. So we hit continue and we hit OK. And there is our output right there. And we are about halfway there. And just to show you, there is the information that we need to do the 95% confidence interval. So it's a 95% confidence interval of the difference, very nicely labeled as your 95% confidence interval. So we were asked to calculate a 95% confidence interval. We have done that. The next one that we wanted was an 80% confidence interval. So let's go back to the data editor, and this is one of the things I like about confidence intervals. It is very easy to calculate multiple confidence intervals one after another because you can go back to analyze, back to compare means, back to the independent samples t-test, and when you click on that, notice it's already all set up and waiting for you. We just need to go back to options and change that 95 to an 80% confidence interval. And then we hit continue, and we hit OK. And notice SPSS has calculated a new confidence interval, this time an 80% confidence interval of the difference, and very nicely labeled. So SPSS is being very friendly and letting you know, just in case you forgot what percentage you put in there. Maybe even if you had a typo, it'll let you know that you have, this time, an 80% confidence interval. And let's finish off this analysis. So the last one we wanted was a 99% confidence interval. And these are the three kind of typically most common confidence intervals. So let's, there we go. Let's get back to the data here. We'll go to Analyze, Compare Means, Independent Samples t-test. And once again, nicely all set up. We go to Options, change the 80% to a 99% confidence interval. And you can do these anywhere from 0 to 99.99999%.
It should just be speed.
All right, so we got our 99% confidence interval ready to go. So we will hit Continue, we'll hit OK. And once again, SPSS has calculated the t-test, and in addition, this time the 99% confidence interval of the difference. So now that we have those calculated, it is time to do the analysis and take a look at where we can find the information that we are looking for. So we have our output. So now it's time to find out where is the info that we need in order to complete this test. All right, so there we go. Okay, so what we're going to do is we're going to zoom in to the 99% confidence interval of the difference here. And once again, just as an aside, we won't go into too much detail here because we've all been practiced with doing these t-tests. But once again, it is in your best interest to make sure that you just double check a few things so that you know you've entered in your data correctly. So do not forget about this top table up here. So we got 15 in the smashed into group, we got 10 in the hit group. We got a mean of 40.8 for the smashed into. We got a mean of 34 for the hit group. That's what SPSS is telling us it has. That's exactly what we want it to have. So that gives us confidence that we've done everything correctly. We're going to take a look at the 99% confidence interval of the difference, because it's got that interesting lower and upper negative and positive version here. So we'll take a look at that, but let's start breaking this down piece by piece. So the first thing to point out, much like before, we are staying in this first column. So just the way we did it for t-test, that first column is that first row is the row that we're going to use. Equal variance is assumed. Equal variance is not assumed. You'll learn about that in grad school, but for right now, we're sticking with equal variances assumed. If you want to know the bits and pieces of where your confidence interval is coming from, if you want to know, where all of the little parts are coming from, so you have your population difference, so we're trying to get the difference here, and that is going to equal the mean difference plus or minus t times your estimated standard error. If you want to know how to find that t statistic, you need to look that up for whatever level of confidence you have, and SPSS will help you by, once again, giving you the degrees of freedom. But again, you don't have to do this because we have the output right here. And if you want to know where that estimated standard error is, it is right there. So this will give you an insight into the components of this confidence interval. But thankfully for us, we don't have to do that because SPSS has very nicely already calculated out the upper and lower bounds. So again, it's very important to remember that SPSS has calculated these upper and lower bounds. Do we have any of that work? But we don't want it in that format. We want it in this format. We want it in that mean plus or minus some range. We want it in that format because, again, that is what most people can make sense of. What SPSS gives us is it gives us this range right here. So we have, in this range, we have an upper limit and we have a lower limit. And then it'll also tell us where our center is. So let's start off with the center. So again, we have our center here, and then we have our upper limit to our interval, and we have our lower limit to our interval. So where is that center? Well, that center SPSS calculates out for you, and it's this one right here, the mean difference. So this is an indication or an example of a estimate that is asking for the difference, right? Because we wanted to know how much was the speed overestimated? How much more did she remember because of the way that the question was phrased? Not what was her estimate, but how much more was it than her true memory? So that's a different confidence interval. So for that, we get the mean difference, and very nicely, SPSS gives it to us right there. So the other information that we have now is we have this upper and lower bound. So the lower bound is all the way down here at minus 0.46. So it could be that she overestimated her memory by minus 0.46 miles per hour, which means that she actually underestimated how fast she was going, or how fast she remembered. On the upper limit, we have 14.06. Right? So she could have overestimated all the way up to 14 miles an hour. Our best guess is 6.8 miles an hour. That's the center of our interval. That's our point estimate. That's our best guess. So when we put it into this format, like you will have to do for your homework, this first portion here, this point estimate, that's your best guess. In this case, it's the mean difference. It's 6.8 miles an hour. So if somebody wanted to know just what was your best idea, what was your best guess, 6.8 miles an hour would be your answer. Now we have to figure out how long are these intervals here. And one of the easiest ways to do that, one of the ways that'll get you there every single time, is to take the upper bound, in this case 14.06, minus the lower bound, which is 6.8, and we end up with plus or minus 7.26, I think.
And this gives you what?
That gives you the interval. So this distance here is 7.26. Right? So this arm here is 7.26. This arm here is 7.26. If I've done my math correctly, it kind of looks like I did. All right. So that's how you get, that's one of the ways to get this arm over here. There's a few other ways. If you have a way that works for you better, feel free to do that. But you can always do upper minus your middle, and it'll give you the length of this arm. And it doesn't matter if your upper is positive and your middle is positive. It doesn't matter if your upper is positive and your middle is negative. It doesn't matter if your upper is negative and your middle is negative. Doesn't matter. You take your upper minus your middle, you will always get the correct length for that interval. It'll always give you this plus or minus part right there. All right, so that is the calculation. So once again, this was for how much faster are the estimates for the smashed into group. And notice that we got there with the information that SPSS gave us, but we needed to use a little bit of logic, we needed to use a little bit of math, we needed to remember that we're asked for the difference. So make sure that you're paying attention to that, you're keeping that in mind. So it's not just going to give you straight up the answer anywhere here on SPSS, but we have to use the mean difference for the center of your interval, your point estimate, and then we use the upper and lower bounds to figure out your plus or minus portion of your estimate, basically the length of one of your arms. All right, so what do we have here? What does it all kind of mean in the end? Well, if you were that expert witness, all right, let's put yourself in that shoes, those shoes. Let's say that you were called as an expert witness on this court case, and it was very important to determine if the witness overestimated her testimony. Was her testimony of 70 miles an hour actually an overestimation? So here we have the line that says no difference. Here we have the line that actually says there's no difference between her estimation based on how the question was asked or whether it was asked how fast were the cars going when they hit each other. So if your estimate crosses this line, it means that her testimony can be admitted as is. So they bring you up into the witness booth, and you get sworn in, and the defense attorney comes up and says, "What is your best guess?" Right? Our witness said 70 miles an hour. What's your best guess for how much they overestimated their testimony? Well, if you were to ask for your best guess, your one single number, you would tell that court 6.8 miles an hour. She overestimated by 6.8 miles an hour, so she said 70, but that's because of the way the question was asked. What she really meant was 73.2. That's 63.2. That's what she actually meant. So that would be your best guess. But then let's say that the judge steps in and says, well, no, actually not the judge. Let's say that the prosecuting attorney steps in and says, well, you need to be 95% sure that it's actually that amount. Right? We need to make sure, 95% sure that it's actually that amount. Are you 95% sure that it's 6.8? And you would say, no, I am not 95% sure that it's 6.8. However, if you want me to be 95% sure, then it's 6.8 plus or minus 5.35 miles per hour. So notice that 6.8 plus or minus 5.35 is all in the overestimation side of this. So this is overestimation, This is, she got it exactly. This is underestimation over here. So you can be, what this means is that because it does not cross this line, you can be 95% sure that she overestimated her testimony. So if they ask you, can you be 95% sure that she has actually overestimated her testimony? You would say, absolutely, I am 95% sure because the entire 95% confidence interval is in this overestimation area. If somebody else steps in and says, well, are you 80% sure? Which would be a silly question because you're 95% sure. But if they ask, are you 80% sure? You would say, yeah, I'm 80% sure. In fact, that 80% confidence interval goes from 6.8 miles an hour plus or minus 3.41 miles an hour. But then here's where it gets really interesting. Let's say that the judge at this point steps in and says, listen, in order for you to enter this testimony in order for us to consider this testimony, we have to make sure that you are 99% accurate. We have to be sure that you are 99% sure that she overestimated her testimony. Otherwise, we cannot admit your expert evidence. So then they would ask you, are you 99% sure that this witness overestimated her testimony? At that point, you would say no, because that is your 99% confidence interval. So I did get the math right. So that's your 99% confidence interval, 6.8 plus or minus 7.26. And notice that it is wide enough that it actually covers this potential that she had no difference, that she did not overestimate at all. So basically, zero overestimation is part of this interval. Up to almost half a mile underestimation is part of this interval. So you could not be, in this situation, 99% sure that an overestimation was made, because the 99% confidence interval covers underestimation as well. So this is an interesting situation where it's very likely you're 95% sure that she overestimated, but you cannot be 99% sure because that one actually contains underestimation as well. All right, any questions on this calculation and just independent means, t-test calculations in general? Yep.
So we always have to subtract the mean from the upper limit?
Yes.
Is there ever a case where we have to subtract the lower limit?
Well, the answer to that is no and yes, and I'll explain why. So no, because this move here will always get it, right? So there's at least three ways to do this. One way is this way, and if you do upper minus middle, or your upper estimate minus your point estimate, it'll work every single time. If you do middle minus lower, that will also work every single time. If you do upper minus lower and then divide by 2, that'll also work every single time. So that's what I meant by whatever kind of makes sense to you, whatever works for you, whatever way you like to do things. But just in case you're looking for maybe like just one way that's guaranteed to work that you can kind of learn at this moment and say, all right, that's what I'm going to get to it. Upper minus middle will always work. And it'll always give you the same answer as the other two ways. So there's three ways to do it. I'm just going to focus on that upper minus middle because that, to me, seems to cover the most situations where it doesn't run into like double negatives or anything like that very often. Make sure you know how to deal with double negatives. Make sure that you know if you're subtracting a negative, how to do that. But that will work every single time. Any other questions on the independent means t-test before we go to the dependent means t-test? All right. Okay, so back to the dependent means t-test. So once again, we're in a situation here where we've already run the t-test. We know that there is a difference. We know that people are higher in accuracy in the 10-second timeout condition than they are in the 5-second timeout condition. Now we might be called by a professional organization that wants to implement this for their commissioned employees, and they want to know, look, how much more accurate are they in the 10-second timeout condition? Because if they're implementing a timeout condition for their employees, that means that their employees are not working. They're not getting commissions during that timeout period. So you want to make sure that you can crunch the numbers and you can say, all right, is the trade-off in accuracy going to more than offset the fact that they're going to be in timeout for an extra 5 seconds, right? So these are the kind of decisions that a person running a corporation would need to make. And as a psychologist, you can give them that data, but once again, it's not that there is a difference, it's how big is that difference. So once more, we go back to the original data set that we had before. And once again, the calculation of the confidence interval begins with an identification of which test is required. So once again, we would read through the description of where we got our data from the experimental description. We would see that, where is it here? The dependent variable, each participant completed a series of trials using a 5-second timeout period and another series using a 10-second timeout period. So we have one group of subjects measured in the 5-second timeout condition once, and then measured again in the 10-second timeout condition. So we have them measured in 2 conditions. We have them measured twice. That's the dependent means t-test. So we have already run this data. We already know that the 10-second timeout condition is more accurate. But then we might be asked, how much more accurate were the participants in the 10-second timeout condition? And we are once again going to compute our 95, 80, and 99% confidence intervals. So we'll start off with this. And once again, what we need to do is we need to set up our t-test, this time the dependent means t-test. So I am going to, somebody's enthusiastic about the dependent means t-test. Okay, I'm going to exit out of the output there. I'm going to delete my columns so that I don't get any sort of confusion. And we need to get our data for the dependent means t-test. All right, so we got the 5-second condition, we got the 10-second condition. We've done these a bunch of times so that we know that these are going to go in 2 columns so that every single subject is on a single row. So we will go here and we can just paste that in. var 0003, that's the 5-second timeout condition, but we know that we cannot start with a number, so we're going to call that second 5. And then the 10-second timeout condition, we're going to call that second 10. So again, those are 8 characters or less, so we know that we are super safe. So we have second 5, we got second 10, and we are ready to do the dependent means t-test. We go to analyze, we go to compare means, we go to paired samples t-test. Remember, that is the dependent means t-test name in Excel, sorry, in SPSS. So we go to paired samples t-test, we click on that, and we put in the 5 seconds condition, we put in the 10 seconds condition, and if we were just running a t-test, this is where we would stop, but we're going to go to options, we're going to make sure that it's the first confidence interval that we want, which I believe is 95%. Where did my numbers go? There we go. So the first one we want is 95%. So we have 95%. We hit continue. We hit OK. And we have our confidence intervals. We have our t-test done here. Now, this is where, again, you might want to take a look at your output first and decide if it's in the right order, because SPSS has done this in a particular order, and right now it is not in the order that makes mental sense. And I'll show you what I mean. What SPSS has done is it has gone the 5-second condition minus the 10-second condition. And that gives us a mean difference of minus 7% accuracy. What this means is that in the 10-second condition, they were better in the 10-second condition. So this actually means that they were minus 7% better in the 5-second condition, meaning that they were positive 7% better in the 10-second condition, right? So the 10-second condition led to a minus 7% decrease in accuracy, which is a 7% increase in accuracy. And I don't know about you, but my brain is already getting tired of all these double negatives, right? They're just difficult to work with. And we could do the math, and it would work out in the end, and we would end up with this nice correct overestimation, or nice correct estimate of the increase in accuracy. But why make it so hard? Why make it difficult? Why not take advantage of the fact that we can just easily redo this the correct way? So we are going to, let's just exit straight out of this. So we're going to close the output. We go back to analyze. We go back to compare means. We go back to pair samples t-test. And we just click on variable 1 here. And that double arrow shows up. And we are just going to reverse it. So we got 5 seconds and then 10 seconds. We're just going to reverse it. We got 10 seconds and then 5 seconds. The options up here haven't changed. It's still a 95% confidence interval. We hit continue. We hit OK. And there is a very nice, friendly, makes intuitive sense output that we're going to have an easier time working with. So how much more accurate is the 10-second condition? Oh, it's 7% more accurate. It makes more sense. It's more in line with how we naturally think of these things. So it's going to save us a lot of mental gymnastics. And if you've ever tried gymnastics, you know the more complicated you make it, the more likely you are to make a mistake. Same thing happens in mental gymnastics. So we're going to keep it like this. We have our 95% confidence interval completed. All right, so we go back. We go to analyze. We go back. Any moment. There we go. We go to analyze, compare means, paired samples t-test. Once again, very nicely, it's still all set up the exact same way we left it. So we go to options and we change that 95% to 80%, which is the next confidence interval we want. We hit continue, we hit OK, and we can see that it calculated out that 80% confidence interval of the difference. And we're going to do this one more time, this time for that 99% confidence interval. So once again, compare means, paired samples t-test. We go back to options. This time it's 99% we're looking for. We hit continue, we hit OK, and we have ourselves that 99% confidence interval of the difference. All right, so we've calculated those. Now what we need to do is we need to, once again, interpret it to see where we get the numbers so that we can put this, once again, into this form. This is the form that we want. This is the form that your homework is going to be asking you for. So once again, we want to make sure that we know how to get to that particular looking version of this, this confidence interval. All right, so we are going to take a look at, once again, at the 99% confidence interval. Am I on? All right, so what we're going to do now is we're going to interpret this, and you follow along with your output because I have the mental gymnastics output, unfortunately, still up there. But it'll just kind of show you the kind of things that you would need to do, but you're not going to need to because you are a little bit better at planning it out than apparently I was at this time. So once again, double check that you have, again, the right numbers in your descriptive statistics. Double check that it's in the direction that you want it to be. And then where we're going to find our information, if we were looking for the parts, once again, we have the standard error of the mean. That's that part right there. We have the degrees of freedom. That'll let you look up this part right here. But thankfully, we got SPSS, who will calculate all that out for us. And specifically, they have it right here in this 95% confidence interval of the difference. So we're going to take a look at the 99% confidence interval of the difference. So once again, we are looking for the information that we need for this output here, and then we're going to use a little bit of logic, a little bit of math to end up with the final form of it. First thing we need is we need our point estimate. What's your best guess? So that comes in the form of the mean right here. This is the mean difference. And remember that that's exactly what we wanted. We were asked for how much will the accuracy increase? How much more accuracy is there in a 10-second condition? Basically, what's the increase in accuracy? So we have, in this case, in your output, it'll be 7%. Notice in this output is -7, which means I have to do some gymnastics. So you thankfully did not need to do that. So we have 7%. That's your best guess. What's the increase in accuracy going to be? Oh, my best guess, my best single number, 7%. So that is the center of your confidence interval. And we got that right there. The next thing we do is we need your upper and your lowers. So you're going to see the mental gymnastics in action right now. So my upper is -2.387, but that is the decrease in the going from 10 seconds to 5 seconds. I want the increase going from 5 seconds to 10 seconds. So that negative upper value becomes a positive lower value. And hopefully you can start seeing why it's a horrible idea not to go back and just flip those the other way. Lower value, -11.61, means through mental gymnastics that my upper value here is 11.61. So hopefully these numbers correspond to what you have. Does everybody have those numbers for their 95%? All right, so you see how much easier it is to just go back and flip those around. All right, so now we got the information here. So we have it all laid out. So what we need to do right now is, again, we need to use a little bit of logic, a little bit of math, and we already have our center best guess right there. Now what we need to do is we need to use that SPSS information and basically come up with this difference right here. And again, if you go upper minus lower, if you go 11.6 minus 7.0, we will get to 4.61. So that is the length of half of the interval, 4.61. This side is 4.61, that side is 4.61. And if you just want to give it a shot, notice that if you go minus 2.387 minus -7, you will still get to 4.61. So upper minus middle works in every situation. All right, so we got to compute a 95% confidence interval, 80 and 99% confidence interval. This was the 95 one, so we get 7.0 plus or minus 4.61. And once again, we have our no difference line right there. So if you were in that board meeting and they said, you know, we brought you in here as a psychologist because we're thinking of implementing this change, and one of the members of the board says, what kind of increase in accuracy can we expect if we go from the 5-second to the 10-second timeout condition? And you say, well, you know, it's 7%. You can expect a 7% increase in accuracy. And if somebody asks you, well, are you 95% sure we can get that accuracy? Because I have investments in this company. I need to make sure that I am 95% confident that we're actually going to see that increase. Well, you can tell them, no, I'm not 95% confident in a 7% increase, but I am 95% confident that you'll see a 7% plus or minus 4.61%. So you will at least see 2.39%. I am 95% sure that you will at least see 2.39. You might go all the way up to 11.6% increase, but I am 95% confident that the actual increase you're going to experience is going to be somewhere in this range. I can say that with 95% certainty. If somebody else says, you know what, I got a more laissez-faire attitude towards investing, I got a little bit more, you know, risk seeking in my investment strategies, I don't need to be 95% sure. I just need to be 80% sure. What's your 80% range? And you say, well, 80% confident is going to be 7% plus or minus 2.79%. And then the final person says, you know what, I borrowed money from the wrong people, and if I don't make money on this, it's going to be really, really bad for me. So I can't be 95% confident. I definitely can't go 80%. I got to be 99% confident that this is going to cause an increase in accuracy. Can you tell me that you are 99% confident that this will cause an increase? And you can tell them, yeah, I am 99% confident, because you can expect a 7% plus or minus 6.71% increase. So at least you're going to get a 0.39% increase. And you could get an increase all the way up to 13.71%. And I'm 99% confident that it's going to land somewhere in that zone. All right, so that was our look at confidence intervals. So in terms of wrapping this up, just a few notes here. So first off, just so that everybody is aware, the confidence interval homework, this is an Excel sheet that you will be completing. So it's not in my lab, it's in Canvas, it's in the Excel homework folder. So download the Excel sheet. It has that automatic grading scheme, so feel free to try this as many times as you need, so there's no penalty for trying it over and over again until you get it correct. It is due December 4th by midnight, so you have until tomorrow by midnight to complete this, and you simply upload your completed Excel file to Canvas. And once again, feel free to try it as many times as you like, and be very careful when you're reading the question. Typically when students don't get the answer correct, what they're doing is they are calculating an absolute amount when it's asking for a difference, or they're calculating a difference when it's asking for an absolute amount. So pay very close attention to whether or not the question is asking how much more, is this amount, how much of an increase was there, which is a difference estimate, or are they asking what is the amount, how much of something was there, which is an absolute amount. So it's sort of the difference if you were tutoring, if you were getting tutoring to improve your grade. Somebody might ask you, well, how much has the tutoring helped your grade? And you might say, oh, my grade has gone up 10%. Or they might ask you, what's your grade right now? And you might say, oh, my grade right now is 90%. So remember, pay attention to whether they're asking for an absolute amount, how much is there, or whether they're asking for a change or a difference, how much more, how much less, what is the difference. So that's the homework. And then you also have 2 more problems that you can find in the Excel sheet to kind of practice this out a little bit. The descriptions for those are here in the student slides, as well as the ranges that you are looking for. So I recommend give those a shot to kind of warm up your abilities. And then also you can practice on the ones that we didn't specifically calculate, just to make sure that you got this move down. So we've done, remember we asked for three confidence intervals in every example, but we only went through calculating the one of those intervals. So you can always calculate the other 2 to kind of give yourself a little bit of extra practice, just to make sure that you got everything down pat. All right, so other than that, that is it for today's class. So we got about 10 minutes left if anybody wants to try some stuff or has any questions, things they might like to see. But if you want to call it an early day, feel free, because that is what I wanted to cover for today. Mm-hmm.